So the last big idea we are going to talk about are wholes. This is where the numerator and denominator equal 0 at the same time. So when we are solving or trying to find wholes, we start off by finding potential zeros and potential vertical asymptotes. So I'm just going to make a note to myself, potential zeros. And from the previous video, we know that this is where the numerator equals 0. So I'm going to go, oh, x squared plus 2x equals 0. Like, as always, it's a quadratic. There's a lot of ways to solve it. I see right away that I can factor out an x. So I have x times x plus 2 equals 0. Therefore, x equals 0 and negative 2 are my potential zeros. Now I need to do this again and find my potential vertical asymptotes. And I see, like, wow, that's just x. Like, it's one of those ones that's so easy that it feels hard. But you start out by just going, hey, the denominator set it equal to 0, x equals 0. I did, and I'm actually done. X equals 0 is my potential vertical asymptote. So here's the potential idea. What we should see is, wait, it's a vertical asymptote. That means the function doesn't exist there. But up here it says, hey, it's a 0. That means that the function should exist and it should be a 0. It can't be both things, otherwise it wouldn't be a function. So it's something else. So because, I'm going to summarize again, because we have 0 and 0, it's a whole. And the big question of a whole is, well, where is the whole? So the way you find where a whole is for rational functions is you simply take the factored form of your equation. So we're going to use the factored form of our equation, f equals x times x plus 2 over x. You take a factored form, and then you go, hey, look, I can cancel out those x's. So I can cancel out those x's. Because I did that, f doesn't quite equal this anymore. Right? They're not exactly the same, but they're really similar. So really what we should be doing is we're talking about taking the limit as x approaches 0 of this function. We're taking that limit, this is our little mathematical trick, which allows us to cancel that out. And then we go, oh, now I could plug 0 in. So we end up getting, just getting 0 plus 2, and we find out that there's a whole at 2, at 2. So the coordinates of the whole are 0, 2 from that value. Those are the coordinates of the whole. So again, the whole is the tricky part. We find the potential zeros by setting the numerator to 0. We find the potential vertical asymptotes by setting the denominator equaling to 0. Any place where the values are the same, where it's both, we look and we think it's both a 0 and a vertical asymptote, what we need to do is find the y value associated with that. It's probably a whole. So what we do is we plug in, or we look at our factored form, we cancel, and then we plug in, and we get the value of our whole. So that's it. We are going to practice this a lot. This tends to be the tricky one, okay? So good luck.